Hi, can you see the effect in the left and a planet is in the center, and you can see the sun is appear from the left to the right, and then it disappear. And also you can see a lot of stars. Do you want to know how to make it? Okay, let's start from the scratch. Oh, okay. You can see that now the whole screen is changing to the white. And at first, uh, we utilize the function sphere intersection to compute that in each pixel if it intersects with a sphere. That is, and now we compute the intersection point for our ray to the sphere with the center as the origin and with the radius of 3. Then, if there is an intersection with the sphere, that is, else there is no intersection with this sphere. And firstly, we can make the intersection with the sphere to be white. You can see that here is a sphere. Then at first, we make a tap for the land, for the planet. And the YZW of the result is intersection point of our intersection. Then we use the random value from 0 to 1 to index the type of the planet. Is it land or sea? First, we make the land. Fancy cube is a sampler function from a 2D sampler to for a 3D point. And now you can see the land, right? The tap from 0.5 to 0.6. Then we change it to the land. And when the tap is below 0.5, we make it into C. We first make the shallow C. And first, you can see the shallow sea, and later we make the deep sea. That is, when the tap to be smaller than 0.4. Now you can see the deep sea is far from the land, right? It's far then we know almost there is clouds in the sphere. In the sphere. Now we make some clouds. In fact, we can first compute the intersection point with a bigger sphere. Now we can add the clouds by the factor noise. By the fractal noise. That is, uh, we can use the addition to add the clouds. Now we can add the clouds. You see, the clouds is the density is too high. We need to make it lower. You can see there is clouds that is near the sphere and is floating, right? And is floating, right? And finally, we can add the lighting. We can add the lighting. We consider sun as our lighting source. We can first compute the diffusion. This is a sunlight a direction, sunlight direction. And we can compute the sunlight direction with our normal. And finally, we can add this diffusion to our final color. And you can see now, there is a shadow, right? Now we can add our sun and the stars. Firstly, we add our sun. As we set the ratios to be large, as the sun is very centered. And now you can see the sun, and then we add the glow for the sun. Just make the ratio to be lower. That's okay. Like 20. And we make it to be a different color, like orange. And you can see there is a glow for the sun. And now there is there should be a lot of stars in the space, right? Now we add stars. And now you can see there is a lot of stars, right? And now you can see there is a lot of stars, right? Mm, we can make it to be different color. By the random value. And we can multiply the star color to the stars now. And you can see for our stars, there is a different color, right? It's more colorful. And at the end of this, I will explain to you as a first, we define the sunlight, and then we define the fancy cube function. This is a sampler function. And this is a distance to line function, which and we also define the sphere intersection. This is return the intersection point and the intersection a distance from the origin. And at the end, to add the interactive, I add this. As we can change the sunlight. We can change the sunlight direction by mouse Y. And this is the basic part for the camera. And that's all. Thank you. I hope you can enjoy this.